Hey there, hope you're having a wonderful day. So in the previous two videos, we went over inheritance and protected data members and virtual functions in C++ for object-oriented programming. In this video, we're going to expand upon the topic of inheritance and talk about pure virtual functions and abstract classes. So let's go over what we've written so far. So here you can see we have a base class called game character, and essentially this is going to be the base class for our video game character classes. So we have two data members which are protected, int for health and string for weapon. And we've created three methods. So we have an attack method. So for the base class, the character does not have a weapon and therefore will attack with a punch. And we have a setter and getter for the weapon attribute. So we have a warrior class that inherits from game character, and we override the attack method. If the warrior does not have a weapon, then the warrior will call the attack method of the base class, which is attacking with a punch. Otherwise, the warrior will attack by slashing with the sword. Likewise, we have a mage class that inherits from game character, and if the mage does not have a staff, the mage will invoke the attack method of the base class, which is again attacking with a punch. Otherwise, the mage will use a fire spell to attack. And finally, we have the archer class, which also inherits from game character. And likewise, if the archer does not have a bow, then the archer will invoke the attack method of game character, which is attacking with a punch. And if the archer does have a bow, then the archer will shoot an arrow to attack. So as a recap, let's start by creating an instance for each class. So I'm going to create a warrior, a mage, and an archer. And for each class, we're going to call the attack method. Now, when we create each object, we are not setting a weapon, and therefore, if none of these classes have a weapon, if we call the attack method, then they're going to invoke the attack method of the base class. So let's save and run the program. And you can see for each class, the characters attack with the punch. Now let's set a weapon for each character. So I'm going to do warrior.setWeapon sword, and let's print out the warrior weapon. And I'm going to copy and paste this, change this to mage, this to staff, and this to mage. And let's copy and paste one more time, change this to archer, this to bow, and this to archer. Alright, so now each character has a weapon, and now if I save and run the program, you can see the warrior has a sword, and the warrior attacks by slashing with the sword. The mage has a staff, and the mage attacks by using a fire spell. And the archer has a bow, and the archer attacks by shooting an arrow. So for each class, we are assigning a weapon and calling the attack method. Now, since each class inherits from game character, this means that each class is also of the type game character. Since the type is also inherited, therefore I can create a pointer to game character, and let's call it game character pointer, and assign it to the address of warrior. And then I can have game character pointer called the attack method, and I can also reassign game character pointer to the address of mage. Again, let's call the attack method. And let's do the same thing for archer. Now, if I save and run a program, let's see what happens. And you can see the pointer is pointing to the warrior, and then the mage, and then the archer, and calling the attack method each time. Now, the issue with this is it's calling the attack method of the base class, even though each character has a weapon. So the reason why this is happening is because of the type of the pointer. Because the pointer is a game character type, when we call the attack method, it is going to look for the attack method in the game character class instead of the object it is pointing to. So even though it is pointing to warrior, mage, and archer, because it is specifically a pointer to game character, it is going to look for the attack method in the game character class and not check to see if the method has been overridden. And this is where virtual functions come in. So over here, I can mark this method as virtual, and this method becomes a virtual function. Essentially, when we mark it as virtual, we are declaring that this method can be overridden, and therefore a virtual table will be created when this program is compiled, and the virtual table will map the appropriate method call for each class. So if we have a game character pointer that points to a warrior, it's going to look at the virtual table and decide that it should call the overridden method. And if I scroll down, over here, we can also add a keyword called override. And this signifies that this method is overriding a virtual function. So let's go down here and mark this as override as well, and for Archer as well. Okay, so now if I save and run the program, you can see the game character pointer, when it is pointing to a warrior, it will attack by slashing with the sword. For the mage, it will attack by using a fire spell. And for the archer, it will attack by shooting an arrow. So by declaring the method as a virtual function, the method will now know that it should be calling the overridden method for each class. Alright, so that's virtual function. Now let's talk about pure virtual function and abstract classes. So with classes, I can actually create an instance of the base class. So for example, I can create a game character. Let's call this game character. And I can do game character.attack. And if I save and run the program, you can see here the game character attacked with a punch. Now, let's say I want to redesign this game such that the player cannot create an instance of game character, and therefore the game character only exists to be an interface for the other characters. In that case, what we need is an abstract class. And in order to have an abstract class, we need something called a pure virtual function. So this attack method is currently a virtual function, and in order to make this virtual function a pure virtual function, we must not define this function. So I'm going to remove this and assign this method to 0. And in doing so, this attack method is now a pure virtual function because it is not defined. And when a class has at least one pure virtual function, it automatically becomes an abstract class. And an abstract class cannot be instantiated. So we cannot declare a variable, game character, and create an object. We can't do that anymore since this is an abstract class. So if I scroll back down, you can see we now get an error for the game character. And if I hover over this, it says object of abstract class type game character is not allowed. And the reason why a pure virtual function turns a class into an abstract class is because if we do not define a method, we do not want a user to potentially call that method for a base class. So I'm going to comment this out. And if I scroll back up, let's say for this warrior, if I choose not to override this method, so let's comment this out, you can see I'll get an error. So let's go back down. And so if I hover over the error, it says object of abstract class type warrior is not allowed. And that is because if this warrior class inherits from a base class that is an abstract class and it does not override the pure virtual function, then this warrior class will also become an abstract class. So let's go back up and I'm going to undo this. And now you can see the error goes away. So as long as you have one pure virtual function, the entire class becomes an abstract class. And this doesn't mean that you cannot define methods inside the class. An abstract class just simply cannot be created, okay? So we can still define methods and have them be inherited by the derived classes. And over here, you can see as well, there's no error for the pointers. So we can still have a pointer to a game character, even though it is an abstract class. And that is because a pointer is not actually creating any objects. It is simply pointing to objects that already existed, okay? So if I save and run the program, let's see what happens. And you can see we get errors. We get undefined reference to game character attack. And so if I scroll back up to where we override the attack methods for each class, you can see our earlier logic said if the warrior does not have a sword, then it's going to call the attack method of game character, which was attacking with a punch. Now, since this method is now a pure virtual function, it is not defined, and therefore we cannot call that method. So I'm going to have to replace this. And logically, if a warrior does not have a weapon, we could make it so that the warrior does not attack. Or we can just have the warrior attack with a punch just like before. So here I can do cannot attack without a weapon. And I'm going to copy this, paste it over here and over here. So now we fixed the issue. And if I scroll back down and save and run the program, you can see everything is working just like before for the game character pointer. And if I remove this piece of code, so that now for each character class, we no longer have weapons. If I save and run the program, you can see none of the game characters can attack. Okay, so we get cannot attack without a weapon. Alright, so just as a recap, pure virtual functions require derived classes to override them. A class with at least one virtual function becomes an abstract class. Abstract classes cannot be instantiated, so this means we cannot create an object for the abstract class. However, we can still create pointers to abstract classes since that requires no instantiation. Okay, so that's the idea of virtual function, pure virtual function, and abstract classes. Hopefully you found this video helpful, and if you did, make sure you give this video a like. If you have any questions, let me know down below in the comments. And as always, if you want to stay up to date for more C++ tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.